Okay, now I think we're in the last section of notes. 7-3, day 3. And what's going to be new in here are some, get it on the screen here, airplane and wind problems. Okay, so the airplane has an engine and you can set the engine speed. So that is called the airspeed. That's the speed that the engine is set at. So that's an airspeed vector. The direction that it's going in, they call that the heading. This is your engine. Then you've got wind that can push the plane around. So tail to tail wind. So when the physics behind it, when the wind pushes the airplane around, that's adding the two vectors together. So we would have to slide one of these. It doesn't matter which one. So I could slide the wind down here so that it's head to tail. I'll grab another color. Wind. Or I could have slid the airspeed up, either way. But the resultant, being this diagonal here, is called the ground speed. It's what the plane looks like from the person standing on the ground with the wind pushing with it or against it. That's called the ground speed. And its direction is called the course. Kind of ran out of room here. So if you see course, that goes with the ground speed vector. If you see heading, that goes with the airspeed vector. So let's talk, let's go, let me just say that here first. So wind added to airspeed is equal to ground speed. But we got to talk wind first. So the weatherman, the way he describes the wind, you're going to see is actually just the opposite of the physics that's happening. So the force of the wind and direction of the wind. So if the weatherman says there's a 20 mile per hour north wind today, okay, what he means is the wind is coming out of the north. So if you face north, it's going to blow right into your face. So the actual physics of that wind, instead of blowing north, it's coming from the north, which means it's going to push due south. That's the physics, south. So think of north as 0 degrees. So he's telling you where it's coming from. To see where it's blowing into, we're going to add 180 to that. So the direction of a north wind, its bearing is 180. So if he says there's an east wind, at 10 miles per hour, you know east is to the right, but what he's telling you is it's blowing out of the east, which means it's going to blow everything, push everything to the west. So east is where it's coming from. It's going to push west. So if we think bearings, east is 90 degrees, but the direction this is actually going due west is 270. So we would again add 180 to that and get a direction of 270. So now that the compass directions are there, We essentially just have to change the wind by 180 degrees. So on the problems, what you're going to see mostly is a bearing. So it's coming from a bearing of 45 degrees. So what you have to do is say, well, if it's coming from 45, I'm going to add 180 to it to see what it's blowing into. So I would draw a vector at 225. So let me show you that. So it's blowing from 45 degrees, which means we would add the 180, and then that would mean I would draw it at 225. I should have had this dotted. But let's say he tells us it's blowing from 300 degrees. So like I said before, we're always changing it by 180. Well, if I add 180 to that, I'm going to be at 480. So we don't want to go over 360. So to change it, we can also subtract 180. Besides, we don't always have to add. We can subtract 180. So we're going to go 300, and in this case, subtract 180 to keep it within 360. And that would mean we would draw the vector at 120. So if I wanted to draw a wind vector from 300, I would draw it at 120. Oops. Which means it was coming from that 300 direction. So the point of this is, if you have wind, you have to fix it by adding or subtracting 180. Wind must be fixed. Let's try a couple of problems and see how you do. So number 1. We've got a plane that's heading due south with an airspeed of 206 miles per hour. We have a wind from 56 degrees. That's blowing at 8 miles per hour. Can you find the bearing of the plane? And the ground speed. Okay, so we need 2 pieces of information for all of our vectors, the magnitude and the direction. So we'll start with the airspeed vector. We know that it's going south at 206. So we have both pieces of information there. The wind, we've got the speed, the magnitude is 8 miles per hour. But the direction, we have to fix it. So when we draw it, we're going to add 180 to it. So we're going to be drawing the wind vector at 236 degree bearing. And then the ground speed, we want both pieces of information, the magnitude and the direction. So when we do these, it's always airspeed plus wind. And since I know both pieces of information for both of them, it doesn't matter which one I start with, because we always draw them tail to tail. Those are the 2 forces, and then we slide them and do the math behind it. So let's go with the plane first. It's headed south. Well, that's easy enough to draw, south. 206. Now we've got to put on the wind vector, and we're going to attach it tail to tail first, then we'll slide it. So it's on a bearing of 236, so I need a north reference line, dash that in, start above it, swing around 236, so that's 90, 180, maybe this. And wind is not very long compared to the plane, so 8 miles per hour, so I'm not going to make it very big. And that is 236. So right now they're tail to tail. So I can slide the 8 down or I can slide the 206 over. It doesn't matter. I usually will slide the smaller one. But before I do that, I think I want to find the angle in here. And remember, it's 180 to this south line. I've just got to subtract those to see what the angle is inside of here. So 236, subtract off the 180 means I went by that 19, 20, 21, 22, 23, 56 degrees. So that makes this 56 degrees. Now it's just like a problem we did yesterday. Slide the 8 down. Or I could slide the 206 over. I didn't make a very good parallelogram. And then the resultant is right here. Here's the resultant. And remember, the original angle here was 56. We've got to find this one so that we can do a law of cosine. So I'll go 180, subtract the 56 because the two angles are supplementary. That's going to give us 124. So we can find out how fast the plane is actually moving, finding that ground speed by doing law of cosines. So r squared equals those two squared and added minus 2 times the 8 times the 206 times the cosine of 124. And again, I'm not going to take the time to do all that. I'm sure you're fine with that. You should be getting 211. And I think I'll stick with the 3 sig figs because that one had 3 sig figs. Now direction. It says it wants the bearing of the plane. Well, the bearing, I can physically see that it's just past due south. So the bearing, remember, is from the north all the way around to that vector. That's what I'm looking for the bearing. Well, I know it's 180 to here. I just need to know how much past 180 it went. So that's just finding this angle, which is not half of 56. When you draw that diagonal in, it does not cut that in half. So we use law of cosines again. Now that we've got the other side, actually I can use law of sines. I'll be fine with that because we've got this side here figured out, 211. So I'm going to use law of sines. And we'll go with law of sines says take the side 211. Go right here. Divide by the sine of the opposite angle. I want this angle up here, so that means I need the 8 over the sine of A, I'll call it. So now it's cross products, so those get multiplied, and then I'll end up dividing. So I'm going to do all of the work on a calculator. I will show this one since it's been a little while. I think I'm in degree mode, yep. So I'll go sine of 124 times 8. And then I'm going to be dividing by that 211. And remember, this is the sine of this, so I've got to inverse sine that. So inverse sine that answer. I get a 1.8 degree angle. So now I know that I'm just about 2 degrees past due south. So my bearing will be 180 plus the 1.8. And there it is. So if you pull out, your goal is to get both pieces of information for all of the vectors. Let's try another one. So number 2. Number 2. A pilot wants to fly on a bearing of 74.9 degrees. by flying due east, a 42 mile per hour south wind puts him on course. Find the airspeed and ground speed. Okay, so let's see what all this information is here. Remember, we've got three vectors: airspeed, wind, and ground speed. So I'll identify them. Airspeed, wind, and ground speed. Remember, it's these two added together to give you this one. So if we look back in here, it says he wants to fly on a bearing of 74.9. By flying due east, the south wind puts him on course. So the course is tying back to this beginning one. That's your ground speed. So for the ground speed vector, we know the direction is 74.9 degrees, but we don't know the miles per hour. The wind, I think we know both things about the wind. 42 mile per hour south wind. So a south wind has to get corrected, means it's blowing from the south, means we're going to draw it due north at 42 miles per hour. So we know both of those. So we got a 0 degree bearing and 42 miles per hour. It says by flying due east of 42. So the airspeed vector we know is going east. And then he lets the wind push him. But we don't know the miles per hour. Okay, so I always like to start with the vector that I know both pieces of information for, and that would be the wind. So I will draw the wind first. So it's blowing toward the north because it's a south wind. So I'll start with that. 42 miles per hour. And then the airspeed, let's see, the ground speed, remember, is the answer. So if you look back at the beginning one, the ground speed is attached, because it's the resultant, it is attached tail to the wind. And then we'll stick the airspeed on at the arrowhead of the wind. So let me go to the ground speed since I know that direction. So the ground speed will be on a bearing of 74.9. So I have my north line. I'm going to swing over almost 90 degrees, not quite. So there's my ground speed. This is 74.9 degrees. And then the ground speed, I'll call it G. And now I know, oops, I went up too far because the airspeed vector is going to get attached here. Oh, I could have done this first. It's just due east. So don't need all that. Went a little far. Due east, that's going to make a right angle. This would be your airspeed vector. And now we've got enough information to find both of those. You could do law of sines. I'm going to prefer to stick with SOHCAHTOA. So I'm going to stand here, and I'll go opposite over adjacent. That's a tan. Equals A over 42. And then this one would be adjacent and hypotenuse. That would be a cosine. So cosine of 74.9 adjacent over hypotenuse. And if I do cross products here, this one's just a multiply to get the A, the airspeed vector. Let's see what I get here. Tan 74.9 times 42, 150, I'll just round it off to 56. This one here is going to be a multiply and then a divide. So it's going to be 42 divided by cosine of 74.9, 161. These were both miles per hour. Okay, let's try one more. Ooh, 10 minutes. Okay, number 3. We are flying at 168 miles per hour. He wants to be on a bearing of 57.6 degrees. We have a south wind, which means it's blowing into the north at 27.1 miles per hour. Can you find the bearing the pilot should fly and the ground speed? Okay, so again, dissect what's given to you. Figure out which information is going to the airspeed vector, which information is the wind, and which one's the ground speed. So the airspeed vector, wind, those get added, and then we've got ground speed. Okay, let's get the wind. We've got a south wind, which means we're going to be drawing it due north. Sure, we shouldn't have that. And then 27.1 miles per hour. So we have both pieces of information there. It says he is flying at 168 miles per hour. That's your engine speed. And you can ask me if you're not sure, but that's the engine speed. So that would be the airspeed, 168 miles per hour. We have no idea what direction. And it says he wants to be on a bearing of 57.6. That's your end result, where his end goal after the wind pushes him. So that means we don't have the miles per hour. I better call it another letter, Y, miles per hour. But we do know the direction is 57.6 degrees. Okay, so just like before, I'm going to choose to start with the wind vector. So the wind is blowing into the north at 27.1 miles per hour. I do know the direction of the ground speed, so I'm going to put, because if I try to attach on the 168, I really don't know what direction to put it in. I just know that it's kind of long. But once I get the ground speed in, because remember, ground speed and a wind are tail to tail. Right here. The wind and the ground speed are tail to tail. So I need to swing over from the north 57.6 degrees. And I don't know how long or how much force is on that. And now I'm just going to add on the airspeed vector, because wind, after you do the physics, it's at the arrowhead. The airspeed vector is at the arrowhead of the wind and ends at the arrowhead of the ground speed. So that means it's going right here. This is 168. But we are looking for the bearing here. So the bearing of this airspeed vector. So that means I need to know how far over from due north that is. That's what I've called X. So bearings are from north, remember, and just try to keep all that straight. So what we have to do is, see what we've got here. We've got an angle on the next two sides. So that's angle side side. That's law of sines. So let's be careful. What we can find first is we've got these two we can set up a proportion. We'll be finding this angle over here, even though I don't need that one as one of my answers, but that's what I have to find next. So let's call this Z. So I've got 168 over the sine of 57.6 equals, and we'll go 27.1 over the sine of Z. do some cross multiplying, dividing, and inverse sine. So I'll multiply here. Sine of 57.6 multiplied by 27.1 divided by 168. That's the sine, so I'll inverse sine that. 7.8 degrees. Now I can do a 180 trick to get this angle here. So 180 minus the 57.6 minus the 7.8. Oops. 114.6. Then if I want this angle out here, I'll subtract from 180 again. 65.4 degrees. So there's the bearing. It's going to aim at 65.4 degrees. The only other thing left is to find this speed, which I can do law of sines again. So I can say y over the sine of 114.6, that was terrible, equals, I'll go 168 over sine of 57.6. And we'll do a little cross multiply and divide and get 181 miles per hour. So picked up some speed with that wind. Okay, we got a few problems to do today, and we'll call that good. Ooh, just made it under the wire.